Okay, I'll be quick because I just want to give you, we're going to restrict our attention a bit from the whole intelligence to some other slightly smaller piece of inquiry. And this is just a bit of the context where we start thinking about this. And perhaps, notice it's a pretty good time to study problems related to learning, because to some extent, a lot of the intelligent systems that start to be working today have kind of this general flavor that they use data. So they're systems that are data-driven systems. They're not explicitly programmed with rules, but actually use data to achieve the goals they try to achieve. And here is just my ever-updating selection of things that are some kind of data-driven machine learning engine inside, and they start to work enough that you can actually produce sell products based on them. And it's about stopping a second and asking what's next, and try to think what are the challenges we can look ahead. And perhaps looking at the current AI system, one couple of things that pops out are they require a lot of computation, but perhaps even more so, they do require a lot of human intervention still, human supervision, either in terms of engineering or in terms of especially labeling, annotation, and stuff like that. And so one possible direction which we think it's important is comparing to what it's happening in humans, perhaps, and perhaps thinking that what we really would like to do is to reduce the number of samples, not that much in general, but those that require human supervision, so the labeled data, so to say, as we call them. And so it's with this in mind that we looked a bit at the typical, say, machine learning pipeline or data-driven system pipeline, noticing that to some extent at this point, there is a certain agreement that you need lots of data and you need big computers as much as you can of both. And then there is a lot of different kind of stuff that you can do at the end of your pipeline, but then you need the secret ingredient. And the secret ingredient is oftentimes where you boost things, and if you get that right, you can even change perhaps a bit what you're doing in the end, doesn't really matter. And the secret ingredient for many people is data representation. When you get the data representation right, I'm thinking, say, images, you got pixels, then you won't really use the pixel themselves. You want to somewhat process this information. Once you get that right, oftentimes you are halfway through solving the problem, okay? And one thing we notice is that, definitely, for example, this stage of the story is definitely developed, so when it's mature field, both of computer science and applied math and engineering. Definitely when we go and look at what's done in unsupervised, sometimes unsupervised, sometimes supervised data representation, we see opportunities. There is a lot of things going on, and there is relatively little understanding. So it looked like a perfect time to stop and gather a bunch of experts in the field to try to discuss, what's next, what should we focus on, how should we navigate this large amount of exciting observation that we still cannot put in a good order. And here I was looking at this paper by Tommy and Steve Smale of a while ago where they were predicting, I think it was almost 10 years ago, predicting supervised learning becoming a key technology to deal with data. And they were not talking about machine learning, as I remember. They were actually talking about supervised learning. But perhaps right now, supervised learning, we know how to handle, and now it's time to move on and look at not the whole unsupervised learning, but specifically the subfield that one might call data representation. And so this is what got us you all here. And so I just want to show you real quick, probably most of you already saw the program. We try to divide the program in sessions. Each session is going to have 2-3 talks and a final panel discussion where we hope to have, Tommy said, interesting question, but also fights or something like that, so just to make it lively. So the 4 topics are going to be, the first one is really vision, so try to see what has been done in vision and try to put some context over some of the future discussion, and then moving on to learning feature representation. And here, in some sense, these two are somewhat similar. Here, we are going to focus more specifically on, say, deep learning or hierarchical learning. So stacking different layers of computation, try to ask questions like, why do you want to do it? And what's the benefit of doing that? And heading with a bit more of an open-ended section of what's beyond what we'll see coming along, looking further down the line. So I'm going to perhaps skip this a bit because you basically have it. You should all have. You can check just the web on the workshop page, or there are a bunch of programs outside. So the first session is today afternoon. Then there will be 2 sessions: one tomorrow morning on the learning feature representation, and then tomorrow afternoon to end up Sunday morning. Okay, so I guess that's more or less all I wanted to say. So I also want to thank you, everybody. I hope it will be fun, and perhaps we can just get started. Well, yeah, there's one more thing, perhaps. So I want to take the first chance to thank the real organizers like George and Kathleen and Felicia to help me actually get this done. I just did the fun part. They actually did the serious, their serious part. So I just want to thank them all. And to keep exploiting it, say that if you have any questions besides me and Tommy, which are relatively useful, definitely you can try to tackle them, and they will certainly be useful for any kind of questions you have. So, well, I guess now we're really done.